section 5.1, problem number 61 looks like this. It says, identify which of the graphs could be the graph of a polynomial function. For those that could, list the real zeros and state the least degree the polynomial can have. For those that could not, say why not. So there are two of these four pictures here that would not be polynomial functions. That would be number 63 and 64. 63 is not a polynomial function because there's a hole in the graph and it like jumps. 64 is not a polynomial function, it's an absolute value function because it has a corner instead of a curve. Polynomial functions are smooth and continuous. This is not smooth, this is not continuous. But both 62 and 61 are smooth and continuous, so they can be polynomial functions. Now notice how the ends of the graph on 61 are going opposite directions. That means that it has to be an odd degree. Okay? Also notice how this function has two terms in it. In order for it to have two terms, it would have to be at least degree 3. It could be degree 5 and still have only two terms, or degree 7 and still be only two terms. But at the very, very least, it has to be degree 3. The zeros are right where it crosses the x-axis, so there's a 0 at -1, there's a 0 at +1, and a 0 at +2. I think that's the entire problem. So let's go ahead and do 62 though too, even though it might not have been on your assignment. I just want to see the difference between these two. So this one, because the ends of the graph are up, it has to be an even degree. And because there's 1, 2, 3 turns, that means it has to at least be degree 4. Degree 2 isn't enough, because degree 2, a quadratic, is always a parabola shape. It never has other turns in it. It always just has one turn. So in order for it to have 3 turns, it has to at least be degree 4. It could be degree 6, degree 8, but at the very least degree 4. So that's what it's asking. Get the idea?